Hey students, okay, so let's get into some special examples with infinite sequence. And I've had quite a few people ask me about factorials. So we're going to jump right in. All right, so our examples involve factorials. Here we are. Let's determine whether the following sequence converges or diverges. If it converges, determine its limit. Very quickly, just to remind ourselves something we mentioned in class, what is factorial? Well, the factorial comes up a lot in probability and permutations. And what is factorial? Well, it's a shorthand notation for writing a product. 5 factorial is just 5 times 4 times 3 times 2 times 1. Or, in other words, if I have n factorial, that is the number n times a value which is 1 less, so n minus 1, times a value which is 1 less than that, which would be n minus 2. And we would continue all the way down to 3 times 2 times 1. Of course, assuming n is bigger than 3, right? So that's n factorial if it was shaped up that way. But n factorial is just the first number, and then we multiply by 1 less all the way down until we get to the number 1. So how does that come into play with what we're doing? Well, we're taking a limit as n goes to infinity, right, to determine our convergence or divergence for each of these sequences. And we've got these factorials. Now, if I plug infinity in, I have infinity factorial on the top, infinity factorial on the bottom, right? And, well, we get indeterminate form. So really, it would be much nicer if we could reduce or simplify this expression before we took the limit. So let's actually do that. Let's simplify this expression before we take the limit. Now, we just said n factorial can be rewritten as n times n minus 1 times n minus 2, etc. And so why don't I go ahead and write that down on the bottom? N factorial is n times n minus 1 times n minus 2, all the way down to 3, 2, and 1. How can we rewrite n plus 1 factorial? N plus 1 factorial starts with n plus 1, and then it goes 1 less. What's 1 less than n plus 1? Well, 1 less would be n plus 1 minus 1, or just n. And then 1 less than n is n minus 1. And 1 less than that is n minus 2. And we'd go all the way down to 3, 2, 1. And why is that good? Well, that's good because you guys see, right? Lots of things can simplify and cancel when I have factorials that are similar. In fact, n times n plus 1, n minus 1 times n minus 2, all the way down cancels from numerator and denominator. And that gives us the limit as n goes to infinity of simply n plus 1 in the numerator. Ha! Now, let's plug infinity in. That tells me that the limit of n plus 1 is just infinity. This is not a finite number. So what do we say about this sequence? This sequence definitely does not converge. It diverges. And there is no limit. Okay, that was the first one. The second one has factorials, but it's a little messier. All right, but I think we want to do the same kind of trick. We want to start by simplifying the numerator and the denominator. Now notice, this time I don't just have n factorial, I have 2n factorial. But it follows the same rule. 2n factorial is the same thing as taking 2n and then multiplying by 1 less, 2n minus 1. And then 1 less than that, 2n minus 2. And then 1 less than that, 2n minus 3. And then 1 less than that, 2n minus 4. Are you with me here? and we would continue all the way down to 3, 2, 1. How about the bottom? Well, we've got this 4n cubed that is not a factorial, and so we'll just write down 4n cubed. Can't really do anything with that part. But we can rewrite 2n minus 3 factorial. And notice this time, 2n minus 3 is the object or the value that I start with. So 2n minus 3 goes first, and then 1 less, 2n minus 4. And then 1 less, 2n minus 5. But you know what? I don't need to do any more. I'll just go down to 3, 2, 1 because I see a pattern. Notice the 2n minus 3 actually cancels from both the numerator and the denominator. So does the 2n minus 4. So would the 2n minus 5. And so would everything that comes after 2n minus 3, right? And what does that leave us with? Well, let's see. So this is the limit as n goes to infinity of, and what's in my numerator? So I've got 2n, and then I have a 2n minus 1, and then I have a 2n minus 2 over 4n cubed. Well, if we want to, we could multiply out the top. And why don't I do that just to show you? There is a short way, but I'll multiply the top out. What's that? 4n squared minus 6n plus 2 on top times 2n over 4n cubed. Is that what you're getting? And then if I multiplied it all the way through, I'd have the limit as n goes to infinity of 8n cubed minus 12n squared plus 4n all over 4n cubed. But notice, what's really going on is that, again, I have an infinite polynomial in the numerator. A polynomial in the numerator, a polynomial in the denominator, and when I take the infinite limit, it's going to give me this indeterminate form, infinity over infinity. And so really, the only pieces that are most important are the highest degrees. And again, this is because I'm going to infinity. And so I really only need to narrow in my focus and look at 8n cubed over 4n cubed. And that's just 2. That is a finite number. And therefore, we would say that limit does exist. And in fact, our sequence, a sub n, converges, and it converges to 2. All right. I hope this helped with all those factorial questions that you guys might have. Send me some more questions via email and I'll make up some more videos. Okay, good luck guys with the sequences.